Right, this is video 8 for geometry, and we're going to be talking about parallel and perpendicular slopes. So first, let's just remind ourselves of all the different types of slope. And when we read slope, we read it just like we read words on a page, is left to right. So a positive slope would start down and go up, okay, because that's in a positive direction. Negative would be the exact opposite. We're going down, kind of like down a hill. Okay, zero slope doesn't move up or down, it just stays constant. All right, and undefined would be a vertical line. All right, and with those, we would go over however many, but then we keep going up forever and ever and ever, so we can't divide by zero, okay, or by infinity. So that's just kind of a quick reminder of our slope. Remember, to find slope, which is m, we're going to take the difference of the y's divided by the difference of the x's, and it doesn't matter which one goes first as long as it goes first on both the top and the bottom. So for example, if we were to find the slope of AB, where A is -2,7 and B is 3,7, we're going to subtract the x's, and let's just go ahead and call this x1, y1, x2, and y2. So let's go ahead and we'll first subtract our 7's, 7 minus 7 over, and let's just say this is our second pair. So 3 minus -2. So this would become 0 over 5, and anything divided by 5, or I'm sorry, 0 divided by anything is just a 0. So our slope here is 0. So this is just a flat horizontal line. All right, we're going to be talking about two types of linear equations: slope-intercept form, which is just y equals mx plus b, and point slope form. And so we're going to get into that one here in just a little bit. So first, we just have to find the equation of a line that passes through these 2 points. First, we will need to find our slope. So I'm going to call these two my 1's and these my 2's. All right, so to find my slope, I'm going to take 8 minus 5 over 2 minus -3. Now, if you do this backwards, if you say 5 minus 8 and -3 minus 2, you should be able to still have the same answer, okay? And so this reduces just to 3 over 5. Now with our slope-intercept form, we plug in everything that we know. Okay, so we know y equals our slope times x plus b. B is our y-intercept, but we don't know what that is yet. But what we do know are an x and y coordinate to plug in for x and y. Now, it doesn't matter which one you plug in. I like to use ones that have less negatives because that's a little easier to me. But it doesn't matter which one you do. So we're going to use our second one. All right, and we can simplify this. 8 equals 6/5 plus b. And when we subtract, we get b equaling to, it's 34 over 5, but let's just go ahead and call that 6.8. So now I know my 2 points, or I know my slope and my y-intercept, which are the 2 things that I need to write my equation. So now we can go ahead and write our equation with the 2 things that we know. Y equals 3/5 x plus 6.8. All right, and that is our slope-intercept form. Okay. Moving on, we're going to look at our point slope form. So it's a little different. Some of you guys might have had this last year. It might be new for a lot of you. Same thing, we first have to find our slope. All right, so here I'm going to take 10 minus 3 over 4 minus negative 2. Okay, and this slope simplifies to 7 over 6, and that is our m. Okay, now when doing this, it's a little bit easier sometimes because all you need is a slope and just a point, so it doesn't matter which point. We don't have to find our y-intercept like we did before. So we're going to plug in our slope, and because this is a fraction, there's kind of like a little trick to do this to simplify it so we don't have to deal with fractions, is you're going to take your denominator and put it in front of your y. So we'll take y minus our y point, and we can use negative 2, 3, or we can use 4, 10. Again, I don't like to deal with negatives, and that's just me personally, so I'm going to use our 4, 10. So 6 times y minus 10 equals 7 times x minus 4. Okay, and now we'll need to simplify. So we'd have 6y minus 60 equals 7x minus 28. So I'm going to subtract my 7x on both sides, and I'd have negative 7x plus 6y. And I'm going to go ahead and let's, kind of in the same step, add our 60 over. And that would be equals, so we'd take our negative 28 plus 60, and so then that's going to equal 32. And there we're done with our point slope form. So some people like this a little bit better, some people don't. It's just kind of a preference. We're going to be looking a lot at point slope form. Okay, again, talking about lines, just equations of horizontal and vertical lines. Horizontal lines are flat, like the horizon, and the equation is always y equals some number. There's no x in there, it's just y equals a number, and the slope is 0. For vertical lines, they are up and down, and it's always x equals some number, okay? And the slope would be undefined. All right, our last thing today is talking about parallel and perpendicular lines. So some of this might be a little bit of a review, but we're going to kind of dive into it a little bit deeper this year in geometry. So parallel lines have the same slope and a different y-intercept. So in our example here, we've got y equals 2x minus 4 and y equals 2x plus 6. So those are going to be parallel lines. Parallel lines on a graph never intersect. Okay, they're side by side, they never intersect. If these had the same y-intercept, okay, they would just be the same line. They would coincide. Perpendicular lines have different slopes, okay? They are opposite reciprocals. So opposite meaning if it's positive, we change it to negative, and reciprocal means we flip our fraction. So here we've got negative 3 as our slope. For the perpendicular slope, I would flip this as a fraction because remember, any whole number can be written over 1. So we are going to flip that fraction and then make it positive. So that's how we got the 1/3. And whenever these lines, they always intersect at a right angle. And that's what perpendicular, why it's so important that we know that is because later on we'll need to know that right angle. Okay, so we're going to do this example, same equation, but we're going to find a line that's parallel and we're going to find one that's perpendicular. So using point slope form, So we're not going to be using y-intercept. We want an equation that's parallel to 2x plus 5y equals -10 and passes through the point 4, 1. And we're also going to do that the same for perpendicular. So first, let's find our slope over here. So to do that, I would subtract 2x from both sides, and then we're going to divide by 5. Remember, when we divide by 5, everything's divided by 5. So our slope is -2/5. And when we solve this to find our parallel line, remember, if it's in our denominator, it goes with our y's. So we'd take y minus 1, and our -2 goes with our x's, x minus 4. Okay, let's simplify by distributing. And then we want to get this in that standard form where both our x and y's are on the same side. So I'm going to add over my 2x. So we've got 2x plus 5y, and then at the same time I'm going to add my 5 over. And this equals 13. So once we find our slope, it's a pretty easy and quick way to find our parallel line. All right, over here, we already know that our slope is -2/5. So our perpendicular, and that sign, that upside down T means perpendicular, our perpendicular slope would be 5/2. And that's what we're going to be using here. We flipped our fraction and we made it positive. So for this, we've kind of got our work cut out for us because we didn't have to find our slope. So our denominator goes with our y's, so 2 times y minus 1 equals 5 times x minus 4. Again, you're going to distribute, and then we want to get all our x's on one side and all our y's on the other. So when I subtract my 5y, I've got 5x, we've got -5x plus 2y, and I'm going to go ahead and add over my 2, equals -18. Now some of you will want to leave it like that, which this is acceptable. Some of you guys want to get rid of some of those negatives, so you can just divide by a negative and you can flip all of your signs. Either of these are perfectly acceptable answers. So either answer. Now our last example for the day is we are just finding one equation of a line that's perpendicular and passes through the point -6, 8. So first, let's find our slope, okay? And maybe by now you've kind of found a pattern of our slope, but we want to get our y by itself and find that slope. So I'm going to subtract 3x, and then we're going to divide by -4. So my slope is +3/4 plus 5/2. And all we really care about here is our slope. Okay, so do you guys notice how our slope is just the fraction of our two coefficients, but we always flip whatever's with our y. So this would be +3/4. Up on our other example, it was a -2/5 because this 5 was a positive. So for some of you guys, you might understand that and just be able to do it in your head. Some of us might still have to show our work. Either way is totally fine. So now we just have to find the equation of our line. So 4y minus 8 equals, oh, and we want perpendicular slope. So we are actually we've got to flip our fraction. So our perpendicular slope is going to be negative 4/3. So here we actually have a 3 and a negative 4x, and it's minus negative 6. So that will eventually change to a positive. So we've got 3y minus 24 equals negative 4x plus 24. And I'm going to subtract. I'm going to add my 4x over. So I've got 4x plus 3y equals 48. All right. And again, another little trick is when we find perpendicular, we just kind of flip-flop our coefficients in front of our standard form equation, okay? So that's what happens with those coefficients. Now, I know this was a little bit of a longer video, but it had a lot of important information about parallel and perpendicular lines, how to find our slope.